again to go through the introduction about the G coding and why do we use the G coding and how you are going to learn it in a very simple way. Usually, I always try to encourage the student to learn it in a simple way that don't make them hate. If you have any principle of the programming from another subject, or maybe you know how to do the MATLAB or how to write down the basic lines uh, for example, the basic or the visual basic, it's going to be very easy for you to do the G coding. And also, I'll try, as I tell you again, to try to introduce the thing for you in very simple manner that's going to enable you to write down a simple, well, actually, it's going to be above average level of the G coding. Because actually nowadays most of the complicated G coding is going to be done by the CAD/CAM programming, and that's something we're going to learn in the advanced manufacturing subject. I don't know if Dance is enrolling, but I know that Lisa is in the subject. Okay, so first we're going to introduce to have an introduction to the G coding, and that will be actually the title of this course. And I would like to tell you first what is the G coding and how it's going to be used. So it's just a simpler program, and this simpler program is going to be your communication with the machine. So usually what we have in this photo, as you can see here, is a cutting tool, which is going to be connected to the machine. This is the spindle. The cutting tool is going to be connected to the spindle. We have the jaw which holding the part, and this part is going to be rotate in this case. Actually, this is turning milling operation, so it can do both. But anyway, what's happening is that the cutting tool will rotate in the case of the milling, while the part is going to be stationary somehow. And the movement of the cutting tool will generate the shape on the part. We'll learn how to do that in the manufacturing when we did the cutting for the gear, for example, for the gear shaft. We were moving the cutting tool into a multiple to a multiple positions, and while the part was moving, and by its movement it start to peel the things until we are going to have the final shape. So if you remember this calculator where the cutting tool was moving to a multiple position, peeling the part which is rotating, to move the cutting tool from one point to another is required to have an instruction from the machinist, which is going to be you. So for example, we're going to tell the cutting tool tip head is going to be, in the case of the milling machine, where the cutting tool is going to be something like a cylindrical shape, have a face. And this face, of course, is going to be circular and has a center. Your code is going to move this center around to perform the cutting operation. In the case of the turning operation, the cutting tool is going to have a single tip head. And in our programming, we're going to move this single tip head to a multiple position to do the cutting. Usually you remember that the cutting operation in the turning operation is going to be in 2 dimensions, and the milling is going to be 3 dimensions. That's mean that we should have more simpler programming in the case of the turning, and more complicated in the case of the milling. But the problem is, it's not. Okay, now usually because the process of the milling operation, you can set the depth of cut to a multiple level, and this will be okay. In the case of the turning operation, you have to do something called the caning. So you're going to go for a smaller depth of the cut, like 1 millimeter each time or 2 millimeter each time. But you cannot go, for example, I would like to reduce the diameter of the shape from 50 millimeters down to 40. I cannot set the depth of the cut directly to 5 millimeter to shape the things. So I have to do it in very multiple steps until I get to reach the thing. Now, what we're going to cover in today after this small introduction is going to be, the machine code programs, which known as a G and M code. Now we have another term, which is going to be the M. Usually, we are going to have a multiple code. Everything is going to be G followed by a number, And this number will simply going to define what will be the procedure or the movement is going to be required by the machine. This is going to be followed by a location. The location we would like to send the cutting tool head or center in the case of the milling operation to X, Y, and Z location. Some of the other operations can be the M, and this M is going to be something for the miscellaneous operations like to turn on the spindle, turn off the spindle, turn on the coolant, and turn off the coolant. And of course, we have a huge, long list, something about 80 to 100 code. But what we're going to learn you is going to be the principle, how to use something about 5 to 10 codes only to complete the whole machining operation. So where we can use that, this is an example of the GN code, GNM code programming. Now this is a part which is going to be a bracket, and this bracket is going to have a special profile and multiple holes within. So as you can see here, that every location is going to be denoted by the data we're going to have by the coordination system. The most important thing is, if I would like to make a location on the paper, I should have a reference point. And that's what we're going to learn to at the beginning, is how to set something called the datum point, which is going to be my 0, point. And I will simply going to indicate all the positions of the cutting tool movement with reference to that point. So you can see this is the simple example to perform the profile cutting. That's what we call the profile cutting of this shape. The green circle here is represent the cutting tool. The code we're going to write is not going to be about where is the side of the cutting tool is located. No, it's going to be about where is the center of the cutting tool is going to be located. So every measure, every coordination we're going to have here is going to have an offset by the value which is equal to the radius of my cutting tool. So just remember that it's something like you're sitting in the car, you're driving next to the car, passing the car next to you. So actually, you're not going to be in direct contact with it. You're always going to have an offset, something like 1 meter, and this is going to be something you will evaluate. But in the case of the machining or the programming, you can simply calculate that. And once again, it's going to be very simple. The offset we're going to have between the center of this cutting tool and the path we would like to cut is going to be equal to the radius of my cutting tool in the case of the turning operation. Now, this example is for the milling operation. Another example that is going to be, well, where we're going to have the tool which is going to move in 3 dimensions and perform something. It doesn't have to be cutting. It's going to have something like a built-up operation, something like what we call the additive manufacturing, like the example we have here. So this is the simulation of 3D printing operation. And as you can see here, once again, we're going to move the head to multiple positions by using the X, Y, and of course because the I and the J is the process of making the arc, and we're going to explain this one later, and I'm going to show you even a more simpler method to do that. So once again, the G coding is the G and M coding actually is the main language we are using to communicate with the machine to move the cutting tool head or the head itself, in the case of the 3D printing, to a multiple position to perform a work. Now, we need to create a numerical control program. Now, when we call numerical control, because that's something is going to be read by the machine brain, which is going to be the numerical control system, and this will move the different motors to move the cutting tool in the X, the Y, and the Z location. Just remember something before we're going to go forward, that the CNC machine for the milling operation is going to have 3 axes. The first axis is going to be the Z axis, that the tool is rotated around and going up and down to set the depth of the cut. The X is going to be the longest side of the table, and the Y is going to be the shortest side, or the third hand rule side of the table. In the case of the turning operation, we remove the Y. We're going to use the Z and the X. So how we can do the numerical controller programming? We can do that by doing the manual code writing, like the one we're going to do right now. So in that case, we are going to visualize the machine operation from the drawing of the part. We get the engineering drawing, and then we're going to use our brain to think about how we are going to move the cutting tool in multiple movement to the X and the Y, and multiple layers to the Z direction until we're going to finish the shape. So visualize the thing, and then write down the code using the G and the M codes. Another operation that can create a numerical control program is going to be the computer-assisted programming. It's not the CAD/CAM. It's something like the autocorrection or the autocomplete process that you have in the Word when you start to type, and they get to suggest for you that to use this word or using this line. Something similar was invented something about 45 years ago, back in the 1975. And in that case, you are going to use the blocks, ready blocks. And in these blocks, you're only going to change the files. So the computer-assisted programming is going to be a high level of language, like using the APT or the except, and it's going to simply complete combine into the cut location file, which is going to be the CL file, and the CL file is going to be sent to the machine, and the machine will read it instead of entering the code line by line. And the third method, which is most common right now, because simply is going to do the operation more accurately and more complicated, is going to be by using the CAD/CAM generated program. Now, you will say, okay, now if we have the CAD/CAM, why we still need to learn the G coding? Because when you're going to generate the code from the CAD/CAM, you still need to check every step, because the machine is always doing the thing visually. It's never know what's happening in the real machine. That's one thing. The other thing is that some of the part, it doesn't require to be sketched by a CAD model, then you have to generate the G code for it. You can simply take a look to the part and write down the code for it in 10 or 15 minutes, and then enter to the machine and start the work. This will save you the time. You don't have to get the SolidWorks or the NX. You don't have to have the package for the CAD/CAM. If any code is going to be less than 50 lines, you don't have to do the CAD/CAM operation for it. That thing is going to be something like a technical issue. And of course, going to save you some money, because you need a CAD drafter. Well, when I go to talk about that, I'm talking about you as a machinist, not going to be something like you are in engineers. If you are going to be in the real life, you will find that when you are going to need to do the CAD work, you're not going to do it yourself. If you are the technician, you need to send it to the engineering department, and they're going to do it for you. And this will be wasting of time and money, and of course resources. So in the CAD/CAM is going to be an integrated software for modeling the part geometry, or the KAD. And just remember that the KAD is not going to be only this operation. The KAD is not just making the part by sketching. This can consist of anything. It's design. So this, even the testing you're going to do on the part while you do the sketching for it, like the finite analysis element or the fluid simulation, is going to be part of the KAD. And usually you're going to have the model to be used to create the tool path. And the CL data was going to be transferred to the machine. The part processor was going to be a solder package once again. It was going to generate the G and the code that we're going to send to the machine, upload it, and we'll start the machining in very high accuracy. Now, and what we are going to concern about in this session is going to be the manual and numerical control programming. And during this course, I'm going to teach you how to do the things by hand, starting from next week. Next session, which is going to be, of course, next week. So I will give you some examples even today, and I will ask you to locate the positions, and then you start to move the cutting tool center between it to generate the shape. We'll start in very simple manner, like doing the two-dimension thing. And then we're going to go upward to have 3 dimensions and even higher to do the turning operation. Some of the example is going to be shown here once again to show you how to use the code in a different movement for the cutting tool center. So a numerical control program is simple codes, which called the G&M codes or the machine codes. The run of the part program usually is going to create a component or the part on the machine. What we need to do to create the numerical control programming is have a lines of the codes. Now, each one sometimes is going to be called line, sometimes going to be called blocks, and each will represent the next location of the tool center point along the tool path. So it's something like I'm going to tell you, move 5 meters to the left and then 5 meters to the right left. When I'm going to tell you that, that's mean you're not going to go in a straight line, but you're going to go to the chord line to the next position. And that's what we do. That's if I'm going to tell you to do the thing like the G1, like go straight forward to this position. So we have other codes which are going to make the arcs. Most of the movement required is going to be straight lines and the arcs to make the final shape. We don't have to think about any other complicated movements. Actually, we don't have any other complicated movements. So once again, just remember that we are going to guide the location of this tool center point. I think that I need to show you the pointer here. Is going to be, yep, the location of the tool center point in the next movement. So the line of the code is usually going to begin with the block number to define them. Just number them by n. We can put the n1, n2, n3. But sometimes for simplicity and also to have the ability to add lines in between, if I'm going to make it like N1, N2, N3, and then I said, oh, well, I would like to have a code between the line number 1 and line number 2. So I cannot make the N 1.5. So instead of that, I can make it like the N10. So I'm going to have 9 slots before the line to add any lines. And the next one is going to be N20, so I can put N11 to N19, and so on. Usually it's going to be followed by the G code. And the G code can be anything from the G00 up to G94. The G code will include the geometric motion by the tool, and that's why we call it the G code, because G is from geometric. And we have the M code, which represent the machine function, such as the turning the spindle on or off. Also, we need to set the feed rate of the cutting tool, because I'm not only going to send it to another location, but also I'm going to set what will be the speed required in this movement. Because you remember that we have multiple types of the cutting. Mainly, we have the rough cutting and we have the finishing cutting. Each one is going to have a different feed rate. And this, of course, the spindle speed is going to be changed as well, but mainly for the feed rate. Even at the same spindle speed, if I would like to cut an arc, I need to slow down the feed rate. The feed rate is going to be defined by something called the F code. The F code is not going to be appear at the beginning of the line, but is going to be appeared after the G code. So we put the G to a location, then we set the F value and we set a number. Most of the G codes are followed immediately by the X, Y, and Z value to show the next physical position of the tool center. The programming, once again, is going to be manually by the part programmer, which is going to be ourselves in this course. Also, we can do it by using the CAD/CAM softwares like the SolidWorks and the SolidCAM, the Creo, and the Autodesk. During the next semester, for the advanced manufacturing student, they will learn how to use the SolidWorks SolidCAM. I'm going to show them how to do that. At the same time, they're going to be required to use a software called the NX. And I'm going to give you a hint about the NX in the next sessions. The NX is something similar to SolidWorks, but it's come from Siemens. Now, why I promoting that? Because we had the license of the software in the university. That's number one. Second, it does have the app for the for the CAM operation. Third, it's very useful in the industry. Most of the industry, they're using the SolidWorks and using the NX. So at least if you're going to know both, you are going to be able to increase your chances to find a job. Now, what are the standards G code and the M codes? Once again, we have a variety of the G and the M codes. They can be anything from 0 up to 94. The same thing for the M. Apart from the basic G codes, all other codes are simply going to be a combination of the basic codes written in a shortened manner, like the subroutine or the Kane cycle, and so on. For example, the main G codes you have to remember and use are going to be the following. The first one is going to be the G90. The second one is going to be G91. Now, what are the G90 and the G91? We know that we're usually going to have two types of the coordination. The first one is going to be what we call the absolute. In the absolute, I'm going to reference all the next location to the reference point I choose to be the 0, point. The G91 is going to be set the incremental coordination. That means I'm going to coordinate the next point to my recent location. Now, this will be set once or twice or three times during the operation, because usually we do most of the operation using the absolute coordination. But sometimes for the drilling operation for multiple holes, we are going to define the next location to the recent location. So it's going to be used in multiple times during the coordination. But the most used one are going to be the G00 and the G01, G02, and G03. Now, what are the G00? It's going to be a straight movement without having any contact with the work part. It's something like my cutting tool is somewhere in this space, and I would like to move it to a location at the top of the work part. So I will tell the cutting tool G00 to the X equal 1, Y equal 1, and the Z equal 1. And when I say 1, it's 1 inches. Or you can do it as 1 millimeter. So it's going to be above the 0, point by 1 millimeter, which is the Z value. To the right of the center point, to the origin point by 1 millimeter, and above the center point by 1 millimeter. I'm going to show you that later by drawings. Now the G01 is moving straight line, but doing an action. So by doing an action, I need to set the feed rate value. In that case, now my cutting tool was at the location of the 111 for the X, Y, and the Z, but now I need to move it to do a cut. So it's going to be in contact with the work. It's going to take some load on the cutting tool. So in that case, I need to, of course, define the feed rate and define the next location. Now, for example, my cutting tool, just imagine that this is center of my cutting tool, and I would like to move it to make a full line cutting. So you can see that the side of the cutting tool is attached to my work. So I will say G01, X is equal to 10, the Y is 0, and I'm not going to mention the Z because, oh, sorry. Yeah, I didn't, because I was supposed to mention this one much earlier. Usually the G01 is going to be a movement in 2 dimensions only. It's very rare to use it in 3 dimensions, because this will make a lot of load on the cutting tool that may break it. Now, the other 2 codes we have are going to be the G03 and the G02. The G02 and G03 is going to be the movement of the cutting tool in an arc. I would like to cut an arc shape of my work. If I would like to move the cutting tool from the to the clockwise direction, I will use the G02. If I would like to move it to the counterclockwise direction, I will use the G03. Of course, at the beginning of each operation, I need to start the spindle. Otherwise, I'm not going to have any work to be done. So to start the spindle, we have to define the M03, which is moving the machine at a clockwise direction rotation. And of course, we have to define something after that by using the S, which is going to define the RPM value. When I'm going to finish all the operations, I'm going to make the code M00. I don't have to write anything after that. M00 is going to turn off the spindle and end the program. Other G and M codes are going to be different from each machine controller combination, and even above codes can be vary among us different machine control and controllers. We are going to talk about the G20, G21, and usually all the machines we have in Australia is set to the G21, which is using the SI unit, which is millimeter. The American machines have the G20, which is going to be the inches dimensions. So once again, we are going to write down multiple lines, or what we call the codes, or what we call the blocks. Multiple lines. Each line is going to send the machine to the next location. So the block has going to have a standard form with variation according to the particle motion required to the tool center point and corresponding machine codes to be used. So this is an example of a code line. The first thing we have to add is going to be the block or the sequence number. This is line number 15. It's going to be followed by the G90. I tell the machine that your next movement is going to be using the absolute coordination. Then I will ask the cutting tool center to go to the position straight forward, no cutting operation. That's why I use the G00 to the position where the X is going to be equal to 100.0 and the Y is equal to 50.0 millimeter and the Z is equal to -1 millimeters and using the feed rate of 100 millimeter. So what's happening is that the cutting tool is going to go to this position. Now you can see that the Z is going to be referenced as -1. That means that this -1 is going to send the center of the cutting tool 1 millimeter beneath the top surface of the work part. Another example is going to be the following. Now this one is line number 30. In line number 30, I having the G03. We said that the G03 is going to move the center point of the cutting tool to a counterclockwise position. Stop at the point where the X is equal to -20, the Y is equal to 30, and we have the I and the J. The I and the J, I is 10, the J is 2, is going to be defining the center of the arc I would like to have from the last position of the tool. I10, that means that my center is going to be a positive 10 millimeter to the X direction, while it's going to be 2 millimeter in the Y direction. So the calculation will be done by the machine to write down, to make the arc with a certain radius. So I'm going to show you later how to use another simpler way to write down the radius. Before I'm going to do any programming, I have to take a look to the block item I'm going to use for my operation. Now just imagine you take a look from that way. This will be the top surface of my work part. Again, to do the cutting, well, the work I'm going to cut is going to be within this area. I always try to take it as close as possible to the X maximum value and the Y maximum value for the work part. And of course, same thing for the height. Why I have to take it to as close as possible? Because in that case, I'm going to reduce the waste of the material during the machining operation. Now, the first thing you have to do is take a look to the part from the top. You will choose the lower right point on the side, and this will be what we call the datum point or the 0 point. Then everything will be simply going to be defined to this location. The upside is going to be the y direction, and the long side is going to be the x direction. So the program 0 or the datum point is a point of the job, and sometimes it's going to be on the stock material itself. It's up to you. Usually use the one on the stock material. It's going to be chosen by you as a part programmer, and all the coordinates are going to be referred to this origin of the coordinate system, or this will be the point of the 0x, 0y, and 0z. Again, this was my datum point, and this will be the x, this will be the y. Now, if I'm going to take a look from here, this will be positive z, and this will be negative z. If I'm going to penetrate the work, any level beneath the surface, top surface, is going to be a negative value. So its location cannot be included in the program, but you have to define it to the program. It's going to be defined on the machine itself. Its location has to be communicated to the machine operator using the drawings of the part of the blank as is going to be appears before any machining operation. Usually we are going to define the cutting tool to go to this position immediately. It's not all the, well, we have to define it when we're going to, because you know we're going to have the device on the machine, and we need to define this point where the is going to be a higher level than the device top. Otherwise, we're going to have a collapsing of the cutting tool with device. It's going to cut device instead of cutting the work part. This one is overlapping. Anyway, we have to know just a note that for ease of the setting up and checking that the program does not send the tool into the machine table, the program 0 is going to be often used to be at the top surface of the work part or the work piece at the top left-hand corner of the finished job. So this is an example. This is my work part. I can use it anywhere, which is not going to be a certain location, but we always prefer to take this position. So just remember that this will be left side, this is the bottom left side, and this will be my datum point. And the other location is going to be referenced next to it. Another operation is I can choose it on the work part instead of the blue line, which is going to be the original work part. So this is my product. I can use it at the corner of my product. Once again, it's up to you to choose either. Usually, from my point of view, I usually try to take the part itself, the startup part, to be as close as possible to the final part. And thus, the datum point is going to be here instead of here. Both operations are going to be wrong. It doesn't have a standard location, as you can see here. Now once again, we have to remember what will be the X, Y, Z for the milling machine. This is a vertical milling machine, which is the most common one. You can see that the spindle rotation axis is going to be the Z axis. The longest side of the table is going to be the X axis, and the shortest side of the table is going to be the Y axis. If I'm going to translate that to the workpiece, as you can see here, this is my datum point. If I'm going to move to the right, this will be positive x-axis. If I'm going to move to the left, this will be negative x-axis. If I'm going to go forward, this will be the positive y-axis. If I'm going to go backward, this will be the negative y-axis. If I'm going to go above the work part surface or face, this will be positive z-axis. If I going to go beneath, it will be negative z-axis or the depth of the work. So once again, the x-axis is going to be along the spindle axis, the z-axis, the x-axis is going to be the largest side or the longest side direction, and the y-axis is going to be determined by the right-hand screw direction, where no y-axis for the lathe machine is going to be present. These directions are going to be set so that the motion of the tool will be relative to the table. Is going to be called positive when it's going to be moved to the positive x or y or z direction, and negative is going to be on the opposite side. Okay, so once again, just a note that in actual fact, it may be the table that is going to be moving while the tool may be stationary. That's what's happening in the real milling machine. The x and the y, the table is going to move to the x and the y. It's not like the router. The router, usually the table is going to be fixed, while the head is going to move z, x, and y in multiple directions. Something like the in 3D printer, the cutting tool is moving to the, the head is moving to the x and the y direction, while the table is moving to the z direction. So, okay, now we have to know that in the milling operation, because we're going to need more force because we're using metal, we're always going to move the table instead of moving the cutting tool around. Now, once again, to remind you about the absolute and the incremental dimensioning. That's an example. This example is in inches. You can see that we have the points 1, 2, 3, and 4. Now, each position for the tool is going to be specified by giving its x, y, and z coordinates. We always going to reference that to what we call the 0 point or the program 0 point. Now, in this position, in this example, this will be my 0 point. So if I would like to identify the location of the first point, it's going to be 1 inches to the x-axis and 1.25 inches to the y-axis. Or this one is going to be x equal to 1 and y equal to 1.25. The fourth point is going to be the x equal to 1, 0, 0, and the y is equal to 5.87. As simple as that. When the absolute coordinate is going to be used, the x, y, and z values are going to be always relative to this 0 position. So this will be the, if I would like to make the cutting for this operation, I usually going to be using the G90 code if I would like to make it as an absolute dimensioning. So for example, the first line is going to be G90. I would like to go G01 to the x equal to 1 and the y is equal to 1.25. If I would like to take it to the point number 2, you can see that the x is not changing, but the y is changing. So I'm only going to write down the code, the value for the y. If anything never changed, so I don't have to rewrite it down once again. And this will be simple, a shorthand process. Now for the incremental, and that's what you're going to use usually for the drilling operation. We can call it the chain dimensioning because all the positions are going to be referenced to the recent position. And that's what we can see in this example. So we're using the G91. If I'm going to move it to the first point, I'm going to reference it to the 0, 0 point because this is my recent location. So it's going to be G91, G01 to point number 1, which have the x value of 1 inches and the y value of 1.25. If I would like to move it to the point number 2, I have to reference it to the point number 1. So I have to move from reference to the point number 1 by 1.5 inches. Another coordination process is called the polar coordination. And this one is really to be used right now. It was still using in very complicated operations, like, for example, making the disc for the braking system in most of the advanced car, which is going to have the holes. And this was simply going to be used for cooling out the thing. Now what we can see here, actually the reference is going to be once again similar to the case of the incremental, but it's going to be in a polar coordination. Now, the control statement for the operation. And the control statement is not going to involve any tool movement. Doesn't have anything to do with the G01 or G02 or G03, though it's going to have the G code in the front of them. An example for that is the starting up of the spindle, M03. Set up the feed rate with the F code. Set a pause or moving the dowel for a certain time, and this will be G05. And we have the G25, which is going to be a subroutine call, and this is very common when you're going to use the turnt machine where multiple cutting tools are going to be used. The most important one, and this will decide if your cutting operation is going to be correct or wrong, is going to be the geometry or the proprietary statements of as G coding. The most common one is going to be G00, G01, G02, and G03. These are the only codes which are going to decide the movement of the cutting tool. All these codes need to be followed by the value for the X, Y, and Z. Sorry, I'm just checking an email. Now, we also need to know there's another code which is called the miscellaneous statement. Now, this one has nothing to do with the spindle, and sorry, that doesn't have to do something with the basic operation of the spindle, or maybe it's going to be something out of the spindle, like reading the code and turning on the coolant on and off. Just write down M08 to start the coolant operation. You remember the white liquid we're starting every time we try to cool down the cutting tool and the work part. And also, if I would like to take the spindle, instead of clockwise direction, we can do it to the counterclockwise direction. And also, we can stop the program and set it to be reading from the beginning by writing down the M00. So usually, this will going to take some certain time, so we can take off the part and put a new one and start the operation once again. Now, let's see how we're going to apply these codes. The first one is going to be the G01. Once again, the G01 with the operation is going to be the operation of cutting a straight lines. In this code, we can see that we start the spindle by using the M03. The first line is going to be set that my operation is going to be an absolute movement. So I have to set that we're using the G90. The first movement we're going to have is sending the cutting tool center to a position where it's going to be 30 millimeter to the right of the center, the origin point, 15 millimeter to the above the origin point, and 5 millimeter above the face of the work part. Then I will start the operation. The first thing I will do is I'm going to penetrate the cutting tool below the surface of the work part by 5 millimeters. So I made the code of the G01. Now G01, that means I'm going to have a contact between the work part and the cutting tool. The center of the cutting tool will go down to -5 millimeter beneath the top surface of the work part. To use this operation, I need to have the feed rate of the cutting tool to be 100 millimeter every minute. So basically, this will be a drilling operation. The cutting tool went inside the work part by 5 millimeter beneath the surface using the feed rate of 100 millimeter. Now, the next movement, I would like just to make a straight line. This will be inclined. So I need to set the value for the X and the Y. Just remember, we're using the G90. So this next location should be reference to the 00 point. So I'm moving to the next location where the X value is going to be 80 millimeter. The Y value is going to be 60 millimeter, and the feed rate is going to be 120 millimeter per minute. Now, I didn't wrote down the G01 because I wrote down G01. The next operation is going to be G01. I don't have to write down the code again. Also, the Z value is going to be the same, so I don't have to write down the Z value again. The feed rate has been changed. The X and the Y has been changed, and that's why I wrote down the value for the X and the Y and the F value. I finished with that. I cut it as a straight line. So I need to take off the cutting tool above to the height of 50 millimeters. So I'll write down G00, the Z is equal to 50, and then stop the program and turn off the machine by putting the M00 in the line number 5. So the program 0, of course, is going to be this one. And now the question is, what is the tool diameter? I cannot answer you the tool diameter thing because we don't have too many data about what is the distance from this dashed line to the side. But this distance between the dashed line and the side is going to represent the radius. And this will, of course, going to answer the question about what will be tool diameter. Now, the other example is to make a circular interpolation. In the circular interpolation, I'm going to use the code of the G02 or G03. Once again, the G02, if I would like to make the cut in the clockwise direction. G03, if I'm going to do it from here to the counterclockwise direction. Now let's see how the code is going to be read. Of course, we are going to have the same datum point. This will be my 0 program. I would like to bring the cutting tool to here. This is the center. Then I'm going to move it in an arc to make a shape similar to the horseshoe. So I need to define what will be the next location. At the same time, I need to define what will be the radius. In this operation, we have two different methods to do that. Either write down the radius and the machine will find out what will be the center, or write down the I and the J value, which the I and the J will tell the machine what will be the center, and of course going to calculate the radius accordingly. Nowadays, most of the machine do have the value for, you can enter the value for the R, but the R have some disadvantage. We're going to go through it later. Now let's read the code. M03, that's when we start the spindle on. We're moving to the first location where the G01, that means going to move in the space, where the X is equal to 40, Y is equal to 60, and the Z is going to be 5 millimeter. So I'm still above the work point by 5 millimeter. I don't have any contact between both. Next step is I'm going to send the cutting tool to the specified depth. The depth here is given to be 10 millimeter beneath the surface. So the next line is going to be G01, where the Z is equal to minus 10 millimeter beneath the surface with the feed rate of 100 millimeter per minute. Now I would like to make the arc, and I would like to move in the clockwise direction. So I'll use the code of the G02. The location now is here to the depth of 10 millimeter. G02 is going to move it to next location. So I need to define the value for the X and the Y here before I get to define the radius. So the next location, I'm using the G90. So in that case, is going to be located at the X is equal to 15 and the Y is equal to 35. The Z is not changed. So I'll write down the G02, go to the X is equal to 15, the Y is equal to 35. And during your path, because I'm using G02, so definitely is going to go to a circular shape, use the radius to be 25. So I wrote down that the R is equal to 25 millimeters. Now this is internal. Later we show you that if I'm going to do something similar to that, I think it's going to be a little bit complicated to calculate the radius. little bit, but it's not complicated anyway. Now, another method to do that is using the I and the J. So from this position, go to that position on the clockwise direction, but I need to define the location of the center. So the location of the center is going to be, the I is 40. That means it's going to be X equal to 40 for the center point, and the Y is equal to 35, which is the J. By giving the location of the center, the location of the endpoint, the program will be read by the CPU of the machine, and it's going to do the calculation to identify the value for the radius. So we cut this shape. We go up to 50 millimeter, G0 to 50 millimeters, and then we go to the position where the X is equal to 0 and the Y is equal to 0, and the machine now is going to be stopped by using the M00 code. Now, just let me check how many students do we have so far. Okay, well, it's a good number. I'm going to go through this slide. Sorry, I didn't read that. Okay, now, sorry, I just read that. So first, can we use inside SolidWorks or separate? And the other question was, well, Lucas, do we need to download any software for the coding? Now, the answer for the question number one. For the SolidCam, the copy we have on the VMware does have something called the SolidCam. Does have the SolidCam, and also it have another app which called the SolidWorks Cam. Also, we have a copy of the NX and does have the CAM package. I didn't check it yet, but it's already there because I've been trying to use it earlier, maybe last year, and I'm going to show you how to use it later. Now, do we have to download any code, any software for the coding? The answer is no. Now we learn how to do the code by hand, but you can search for a simulator. In your simulator, you can insert the code, and it's going to show you how the code is going to work. I'm going to give you the link later for the simulator, because usually it's going to last for 1 month only. I don't want to use it now. We're going to download later. And for those students going to do the advanced manufacturing, they can download once again using different email. So once again, for the absolute and the incremental programming, well, actually, we have 42 slides. I don't know if I'm going to finish them all, but the most important thing is going to be the examples we are going to have in the next page. So once again, for the absolute and the incremental programming, we said that we are going to use the G90 if we would like to do it for the incremental point. All the next location is going to be a reference to the 00 point. In the case of the incremental, I'm going to use the G91, and all the next locations are going to be a reference to my recent location. So let me give you a hint about that. Now we have a room. Take a look at the room from the top. I'm going to consider the angle behind me is going to be the 00 point. So I'm going to tell my brain, go to the position where the X is equal to 2 meters, the Y is equal to 1.5 meter. I reference everything from the corner side at the bottom. So I went to there. The next location, I will tell my brain to go to the X is equal to 3 and the Y is equal to 2. Once again, I reference that from the origin point. Now for the incremental, set the things to the G91, and then I'm going to repeat the same process. I will tell my brain to go to the X is equal to 2 and the Y is 1.5. Now I would like to go to the next point that I specified as a 3 and 2, but now from my recent location, I will set go to the X is equal to 1, because I'm already at the X is equal to 2, and the Y is equal to 0.5, because I'm already at the Y is equal to 1.5. So that's how it's worked. It's not that complicated. Now let's have an example of the absolute and the incremental programming for this profile cutting. Now you can see that the purple line here is the profile cut. the brown line here is the tool path. You can see the tool path is going to be the location of the center point of my cutting tool, which is going to be, of course, circular in the milling operation. So this is my datum point, and I'm going to send the cutting tool to a multiple location. Now let's see how it's going to be if I'm going to do it as an absolute value, and what will be the case if I'm going to do it as the incremental value. So in the absolute, I need to define that this is absolute. So I'll put the G90. G01, that's mean I'm going to move from here to the X is equal to 250. That's point at the X of 250. And going up to the Y is equal to 35. So I just send my cutting tool in an inclination of 250 for the X, 35 for the Y from the datum point. Then I would like to go to this position. Now this position, if I'm going to sketch 2 lines here, this will show me the center of this circle. And of course, it's going to be the center of this arc. Before I'm going to go to there, you can see that the location of this point is going to be the Y is equal to 35 plus 125, which is equal to 160. Because I'm going to have the same code of the G01, so I don't have to repeat it, just write down that the Y is equal to 160. Now I would like to move from this position to that position, cutting an arc. In that case, I need to use the counterclockwise cutting because we're moving from here to here. So the G03 is going to be the code. The location of that point is going to be where the X is equal to 210. Now, how did we found that this one is 210? This one was 250. Then we went to the backward to the X direction by 40. So 250 minus 40 is going to be 210. While the Y has been elevated to that level, which is going to be, we know that from here to here is 170. From here to here is 30. So the Y is going to be equal to 200 millimeters. Now the radius here is equal to 40. Now, if I'm going to give you the shape, how are we supposed to know what the radius is? The radius, if I'm going to cut from the outside of the arc, is going to be equal to the radius of the arc plus the radius of the cutting tool. Just remember that. If I'm cutting once again an arc from the outside, my radius of the tool path is going to be equal to the radius of the arc itself plus the radius of the cutting tool. If I'm going to do the cut from the inside, is going to be the radius of, as we can see in the next example, is going to be the radius of the arc minus the radius of the cutting tool. We're going to see that in multiple examples. Okay, then the next line is going to go to the X is equal to 40, go down to the X is to the Y is equal to 170, going to the X which is equal to 0, and then go to the Y is equal to 0 and done. Now, let's see how the thing is going to be happen in the case of the incremental. The incremental, some people see that the incremental is going to be an easier for them. From my side, I think that the incremental is quite tricky. So in the incremental, G91, the first cutting is going to be G01, go to the X equal to 250, Y is equal to 35. This will be my next location. Now I did that because it's going to be the same thing. It's 250, 35 for the Y from the origin point. Now let's see if I'm going to move to this location. This location is a Y elevated by 125. G03, I'm going to move from this point to that point. This point is higher than this point by 40. So the X is equal to backward by 40. So the X is going to be equal to minus 40 because I'm moving to the left. And the y is going to be higher by positive 40. So I'm going to put y is equal to 40, and I'm going to add the r equal to 40 millimeters. Now, to move from this point to that point, I'm going to move to the x is equal to minus 170 because I'm moving to the left. Now, I'm going to go down by 30 millimeter. So G01, okay, by the y is equal to minus 30. Then I'm going to go to left once again. The x is equal to minus 40. Then I'm going to go down by 100 millimeter to the y direction. So it's going to be y equal to minus 170. Again, from my experience, many of the workers, technicians, and the student always get failed to write down the correct toolpath by using the incremental programming. It's required patience. It's required to have a visualization for the thing. So I always prefer that you represent every single point by using the absolute value. To start out with the thing, I'll give you a very simple hint on how to do that. So let's have the talk about the radius compensation, the one I just told you about, on how to be adding or reducing the value for the cutting tool radius. So once again, this is another example. We always going to offset the center of the cutting tool away from the cutting path by the value which is equal to the radius of my cutting tool. You can read this example later. I would like to show you this example, and we did that on the router actually, which is going to be, the only difference is that the table, no, for this one actually the table was moving. This is the machine I used to have a long time ago. Yeah, for this one, the table going forward and backward on the X and the Y direction, and the tool is going down and up for the Z direction. To write down the code, take a look to the shape you have, the desired shape, or we call it the cutting path. Locate the location of the program 0, which is going to be at the top bottom left corner. I think that you use the SolidWorks. You know there's an option called the offset, and you can decide what will be the offset value. The same thing can be done here. You offset the thing by the value of the radius of your cutting tool you are going to use. Now you know that we have multiple cutting tools. We usually try to reduce the number of the cutting tool using during the operation because we are going to have a changing time, which is going to be wasting time for the machining. So we always try to reduce the number of the cutting tools so we can reduce the time of the machining. If I'm going to take a look to that shape, the cutting tool diameter I'm going to use is going to be either to increase the rate of the machining or to use a single cutting tool. To analyze the shape, I can say that the radius of the cutting tool I'm going to select is going to be equal to the diameter of the hole I have here. Or I can use a cutting tool to reduce to making the code of the G02 here by having the radius of the cutting tool is equal to the radius of this arc. So you have two options again. The first option is use a cutting tool, which is going to be both for the profile cutting and the drilling of the holes, or you can simply use a cutting tool, which is going to reduce the coding numbers by using a radius of the cutting tool to be equal to the radius of some of the inside arcs. Okay, so do I have a code for this one? No, we're talking about the compensation. So we have multiple types of the compensation. We have the tool length compensation, and that's what we are going to use when we're going to set up the machine itself. And we have the radius compensation. Usually in the manual programming, like the length of the tool in the drilling and the tapping and extra, or the radius of the cutter, in the case of the milling contours and the pockets, it must be taken into the account when programming the geometrical dimensions of the job. Usually in the CAD/CAM methods, is going to generating the tool path and is going to do the compensation automatically. So again, to show you some trick, what you have to take this conversation is going to be to the left or the right. The cycle statement, and that's usually going to be used in, if I'm going to use to lower down the level, from example, the thickness of 50 millimeters to thickness of 30. So I'm going to repeat the same process multiple times. So I don't need to write down the same code multiple times. I only need to change the Z value for this operation. Something like I'm changing the level. So I will do the removing of the face, then I will go for another 5 millimeters, going exactly to the same coordination. So I don't need to change the whole code. I'm only going to change the value for the depth of the cut. In the case of the turning operation, this will be a more critical operation, because if I would like to cut this shape, I cannot do it directly to go to the top here, then do the cutting of the different contour shape. Instead of that, I need to remove layer after layer after layer. So the same process just keep repeating. And in that case, once again, I don't need to write down the code as it is again. I cannot use it as it is with the same dimension. I only going to change some of the parameter. And I consider myself that the writing down the code for the turning operation by using the cycle statement is one of the most boring operation you will ever had in your engineering life. Once again, the CAM system can create the required canned circles automatically. Now, more details are going to have an example of the CNC programming. We have to remember that these are the dimensions. We are going to go to the right. This will be the positive x-axis. To the left, this will be negative x-axis. You're going forward, and this will be the positive y-axis. You're going backward, this will be negative y-axis. Going to the top, this will be positive x value. You're going down the surface, this will be negative z value. The example we have here is we are going to use letters where A to Z is going to be used to, well, I think this will be discovered by something, but just let me fix that. I don't want to have half jobs here. Why it doesn't exist? Should press escape. Oh, yeah. Okay. Okay. Go back to that. Yep. So once again, we said we are going to use any letters from A to Z to be used to designate the functions, and the numbers 1 to 99 used to designate the location of the meaning functions. So what we can see here in this program, you can see that we use the first thing was the percentage, and I'm going to tell you what will be that. I think that you already used that in the MATLAB programming. That's been ignore this line. Something like the program start flag. You'll start the program from here, and we're going to have a 4-digit number, and this 4-digit number is going to be the program number. So you can recall the same program if you're going to save it on your computer, on your CNC machine control system. Then the line number 5 is going to be telling us that we're going to use the absolute value, and the unit we're going to use here is going to be the inches. Line number 10 is start the motor. Sorry, not start the motor. M06 is going to be the stop the tool changing. Stop for the tool changing and use the tool number 3. Start the spindle at the spindle speed of 1,250 revolution per minute. Then move to the position of the x equal to 1, y is equal to 1 inches. Then go to the height of the z equal to 1 inches and complete the operation. So what you can see here is actually we have to define some certain functions. Then we start the cutting operation. Then we finish by stop something and redo the thing. So something like writing down a letter. So if we can take the explanation of this one, we can see that the code is going to be consist of the following part. The first one, number one, is going to be the system setup. We're going to tell the machine what to prepare before we start the cutting operation. The phase number two is going to be the material removing, or the action is going to be done by the cutting tool. The phase number three is going to be the system shutdown. So once again, it's something like you're writing down a letter. The first section is going to be an introduction. The second section is going to be the core or the content of the letter. And the last one is going to be the closure. So, or the summary of what you've done. Exactly what we're going to do here. So you can see that the percentage mean the program started flag. The computer will know that we're starting from here. 4-digit program number, so you can save it and recall it multiple times, especially in the flexible manufacturing systems. Here we identify that we're using the absolute and we're using the units of the inches. The M06, that means we stop the tool from rotating, so we can change it, or the deterrent, we choose the tool number 3. So the T mean the tool, and the 3 is the number of that tool. Now we start the spindle to move in the clockwise direction, counterclockwise direction, actually this is wrong. And the spindle speed denoted by the S is 1,250 revolution per minute. Now we start the movement. We're using the G00 and G01. Just give me 1 second again to open the door for my wife. Oops, I don't know why it's changed to here. Yep, and then we're going to have the movement of the tool G00, go to the X equal to 1, Y equal to 1. Go to the height of, no, this should be here. Okay, go to the height of the Z is equal to 1 inches. Then the next one is going to be do the actual work. When do the actual work, we have to define the G01 code, and we have to define the feed rate value, because this will be important to do the life calculation for the cutting tool and the set of the rate of material removal. The next line is going to be go to the X equal to 2, Y is equal to 2, using the feed rate of 10, because the movement now is going to be horizontal instead of vertical like the first one. Go to the Z equal to 1 above, and then go to the location where the X is equal to 0, Y is equal to 0, turn off the spindle, and end of the program. Now, the percentage, once again, is the program start flag, is placed at the beginning of each program. It's going to be done automatically, and you will see that when you're going to use the CAD/CAM later. The identification number is going to be after the percentage value, which is program start flag, is going to be a 4-digit number. And that's mean we can have the first program is going to be the 0001, and the last program where the full memory will be used of the computer is going to be the 9999. There are these two commands are the only one that don't start with the numbers, they start with the symbols. Usually different machines, controllers have a different start flag and program numbers to be used for them. The encode, once again, is going to be stay the line number or the block number. Usually, if you're going to have an error, the machine will tell you, oh, you have the error at the n equal to, so you can simply find it and change it. The generally is going to be good practice if you're going to use the increment of each block by 5 or 10s. And once again, this will give you a more additional block to be inserted in between the recent blocks. If you have missed something, or you want to change the line, or you want to add something that you forgot earlier. We have something called the R and the B codes. And this R here is not going to be for the radius. it's another R. If the R code not going to be follow the G02 and G03 is not going to be a radius. So the R code is going to be a retract distance when it's going to be used with the G81, G82, and G83. But if I'm going to put it after the G02 and G03, it's going to represent the radius value. The B code is going to be used to specify the dual time associated with the G04. This is not the full list of the G codes, but these are almost the most codes of the G coding and the M coding we having in the machine operation. G01, rapid transfers. That means again to move the cutting tool freely without doing any work. Linear interpolation with the G01. G02 to make a circular interpolation in the clockwise direction. G03 is going to be the circular interpolation, but in the counterclockwise direction. G4 is going to be the double. The G08, the acceleration increasing or decreasing with the G09. G17, okay, now this is very important. Now, because we have 3 axes, we have 3 planes. And it's up to you, because, for example, if I would like to make a contour shape, I have to do the programming in either the XY, the XZ or the YZ direction. That means we can use multiple planes instead of just the XY plane. To change that, you can use the G17, where all the machines by default are set up to the G17, so you don't have to write down G17 if you start to use your machine. If I would like to go to the Z-axis plane to make a contour shape, or even cutting a spherical shape, I can go to the G18 or the G19 if I'm going to do it on the opposite direction. Once again, G20 means we're going to use the inches. The same function can be done by the G70. And the G21 and G71 are going to be for the metric units. G40 is going to be the cutter compensation to be cancelled. G41 is going to be cutter compensation to be done to the left. To your side, left. And cutter compensation to the right with G42. G70 is going to be the inches format. G71 is going to be metric format, as we mentioned earlier. G74 is going to be the full circle programming to be off. G75 is full circle programming to be on. And G80 is fixed cycle cancel. G81 to G89 is fixed cycles. G90 absolute, as we mentioned. G91 is going to be the incremental. Here are another codes, and once again, we said this is not going to be something related to the geometry, but it's going to be with the machine and other miscellaneous operations, like the M00 program stop, M01 optional program stop, and we have the M02 is the program to be end, M03 is spindle on, M04 spindle on to the counterclockwise direction. Because some of the tools are going to be either doing the clamping, cutting, or is going to be the profile cutting, if you remember that. The M05 is going to be the spindle to be stopped totally. M06 is going to be the tool change. This should be followed by the T number. M08 is a coolant on. The pump will operate and send the coolant fluid. M09 is the coolant off. M10 is going to be the clamp on if the clamps are going to be controlled automatically. Most of the clamp we have is done by hand. M11 is going to be the clamp off. If I'm going to have the automatic clamp, I'm going to use a robotic arm to feed the machine with the part and take it off. And that's what we call the CIM, or the, part of the CIM. It's going to be flexible manufacturing cell. I'm going to have 2 machines, and I'm going to have a robotic arm in the middle to feed the machine and empty it. M30 is going to be the program to be stopped and reset to the start and redo the code once again after the pausing time, which is required to feed a new part, is going to be lapse. The X, Y, and the Z codes we said is going to be used to specify the X's values. Of course, you know that the number is going to be followed. The codes can be defined the coordinates at the end of the move relative to the incremental absolute reference point. The number may be required that specific format to be used. For example, you can use 3.4, or you can use 3.44, or you can even use 3-digit after the point. It's going to be how accurate you would like to have your work at. We talked about the I, J, and the K. Now, if you remember the mathematical analysis, we said that we can simply identify the coordination for the points to be defined I in the x-axis, J in the y-axis, and the K in the z-axis. So any point can be identified like the point number 1 is equal to 5i 6j plus 10k, for example. Now we're using this one to specify the coordinate axis when defining the center of the arc or circle. But only 2 of the 3 are going to be used depending on which plane you are using. So if I'm going to use the XY plane, I'm going to use the I and the J. If I'm going to use the XZ plane, I'm going to use the I and the K. And if I'm going to use the XZ plane, I'm going to, sorry, XZ, yeah. The third plane is going to be the YZ plane. I'm going to use the J and the K. The number following the code will define the prospective coordinating of the center of the arc that you choose. So if I'm going to define the I and the J, I'll put I, and I'm going to define what will be the location of this center point in the x-axis. And the location of that center point, the y-axis, is going to follow the J value. The number may require to be a specific format used, for example, 4.3, which means that 4 numbers before the decimal and 3 numbers after the decimal. Usually, many of the machines will allow you to use the arc code after the G02 and G03, and it's going to be used to define the radius of the arc instead of using the I and the J codes. And the I and the J, once again, is going to define the center of the arc you are going to sketch or cut, and the machine will have to calculate what will be the radius value. Now, one of the problems we have between using the I and the J or using the R value is going to be programming of 360-degree arcs. Usually, the I and the J and or the K will make the 360-degree perfectly, and even it can make the cutting in a spiral shape. The problem we have with the arc coding is that it can go up to 359 degrees, but it cannot complete, as it mentioned here, it cannot complete the 360 degree. So the best performance for using the arc code is divide the circle into a multiple section. I can cut 180 degree, then 180 degree, once again to make the 360 degree. Let's have an example about the I and the J and how we can do the same thing by using the arc code. Now, I would like you to understand this example because it's going to be very important. It's going to be printed in your brain. So what we have here, we would like to make the cut from the purple point to the red point. The start point is 1.1 and 2. The 1 x and the y is equal to 2. The end point is going to be 2 and 1. I would like to move to the clockwise direction, and in that case, I'm going to use the G02. Now, usually, the I, J, and the K are going to be relative to the start point of this example. So we are going to make this one relative to here, if I'm going to do it like this one. So the location of the I, as you can see here, is going to be equal to 0 because it's just below that. It doesn't move any direction in the x-axis. While the location of the J is going to be -1 below that. And the machine will do its calculation to calculate what will be the radius value. Simply, if I would like to make this one by using the arc code, I can say that the radius here from 2 to 1 is equal to 1 inches. So I can write down that the N10 is equal to G02, X is equal to 2, the x-axis for the last position, the Y is equal to 1, and the R is equal to 1 inches. Now, I think that we spent 1 hour and a half, and I don't want to be boring with this session. So I will leave the examples to the next session, where we're going to have them in more details, and even I'm going to write it down on a paper to show you how to do the things, and we can work on that together. I mean that I will give you a hint, and then you are going to write down the codes by your hand. The answer, of course, is going to be available for you because I uploaded this sheet. I would like you to check it. I think that we are going to meet on Tuesday by 7 p.m. If that's good with you, I'm going to make a poll for that so you can select what will be the best time for you. And also, I'm going to start with the next slide at that time, which is going to be the most important thing, which is going to be how we can do the operation management, which step we start first, which step to start, and especially for a similar shape like the one we can see here, you can see that we are going to have a drilling operation and we have profile cutting. Usually, when we are going to do the operation, we need to hold the part on the machine. To do the drilling, I can use a vise, so I can hold from the side and then I can do the drilling, like what we did in the lab for the most of the parts we had for the pump. But if I'm going to do the cutting with the profile cutting around, I cannot hold the part by using the vise because the cutting tool will hit the vise. Okay, so I'll explain to you first the management of the operation, what to make first and what to make last, and that's actually mentioned in the next slide. Okay, and we're going to talk about this one on the next session. We're going to run on Tuesday by 7 p.m. Okay, thank you for your listening, and if you have any question, you can go ask me now, and if not, just watch the video again, and you can write down the questions here. So the other student will also going to have more benefit of the answers. Sorry for that. I talked a lot. Thank you very much, guys, and hope to see you soon. Oh, the recording is going to be available soon, and also again to send you the link for the YouTube. It's going to be much easier to watch it on the phones.